Okay, moving on. How much energy does an even make in a second? Well, I'll use watts. 19.9 nonillion watts are produced in 1 second from this little star. Actually, it's not even that little. 70 astronomical units. What am I even thinking? And the largest prefix that we have, that's 19.9 quetta-watts. That's a lot of watts. A lot of watts if you ask me. Anyway, moving on, there's this other good topic I should discover, and that is basically its dwarf planet. Now, of course, its dwarf planets, you might ask, are mostly, made of, what do you think? They're made of ice, rocks, and other stuff with that too. And some carbon ones too. And and most of them that are not ice planets are normally in, the inner belt, which I'll talk about later in the planet's time. Now, of course, basically, there are quite a lot of these, and so, and they will just basically be there and go everywhere. They're kind of free, I guess. And yeah, there's not really much to talk about them, besides some of them are really cool landscapes, at least in my head. Yeah, unfortunately, they're not real. Now, of course, we haven't forgotten about something. It's rings. How did you even get this? Carbon piled up and other chemicals that allowed it to be blue just randomly just clumped up, and maybe some gas here and there. Just decided to clump up into a ring. And yeah, that's the reason why. So yeah. And yeah, we're kind of done for the star itself and the dwarf planets. But some of the dwarf planets can get bigger than Earth, and some of them are smaller than Mars. Now, of course, there are also other things that we should mention. And those are planets and moons, which we're about to mention. Now, of course, let's mention the first planet. I'm not going by size, I'm going by when they come in the solar system. Kind of like the order of Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. That kind of order. Of course, let's go by the first one. Now, of course, this first one is not that hot. Here, just joking, it's quite hot. And almost 108 degrees. It's in a binary solstice, which means it kind of has more dramatic summers and winters. And yes, it does get a whole lot more colder and a whole lot more hotter because it's basically just getting yanked by this one for far more stable orbit. It's still getting yanked for summers and winters. And yeah, it also has a temperature of 108 degrees Fahrenheit. And it also has an ice moon, not ice planet, and it's negative 116 degrees in Fahrenheit. That's a big cold, isn't it? Yeah, and it weighs around 300 Earths. Moving on to the next one, which is, only 102 degrees Fahrenheit, which is not that hot, but still kind of hot. Now, of course, this one, it's not nearly as hot as the others, but it's still definitely hot. And it will get cooler and cooler and cooler. Now, of course, this one actually has deserts. It's also the first planet with actual glaciers, unlike the first one, which did not actually have any glaciers. There might be some minor ones, but there are no major ones, unlike it, which has glaciers in the poles. Now, of course, it also has deserts, unlike deserts just being all over the place. And yeah, that's really it to talk about. But now let's talk about its moon. It's also both of them are habitable. And the moon, this moon is not that hot, only 68 degrees Fahrenheit. So it's similar to Earth's temperature. It's also similar to Earth's size, too. Pretty nice. Now, of course, there's this. We're going to go to these two, which are kind of a little bit more farther away, but they're quite similar in size and basically everything. Now, of course, these terrestrial planets, Well, the first one, let's talk about this one. Well, they have quite large glaciers when you compare them to the other ones. But it's just that it's only at 89 degrees Fahrenheit on average. And yeah, that's really it to talk about it. Besides it's habitable, it has slightly smaller deserts. Also, this one, which barely even has deserts, but still has deserts, still has some major deserts. Only around 85 degrees Fahrenheit. Yes, it does have the same problem with being a binary. And they basically weigh almost the same, at around 50 Earths in mass. Now, of course, it's also habitable, but it's also slightly colder, and also has a slightly thinner atmosphere to go with that. Now, of course, let's move on to the near dwarf planets, which some of them actually have glaciers too. Now, of course, some of these can get quite big, as I already know, as you probably already know. Of course, let's move on to the bigger gas giant. Let's move on to something bigger. Of course, here is the first gas giant. Not the largest, but the first one. Definitely the smallest gas giant, only 140,000 kilometers. Yes, Jupiter is small. When you compare it to the rest of the gas giants, it doesn't look that big. But yeah, it does look cool. It does have similarities to Jupiter, and it almost weighs exactly one Jupiter, 1.1 Jupiters, which is pretty nice. Now, of course, this one is only around 61 degrees in Fahrenheit. There's a big gap, and that is basically a belt that has a lot of dwarf planets. Now, of course, moving on, we go, to this little terrestrial planet. It's the last terrestrial planet that we'll actually see. Now, of course, this one has a large glaciers, actually, beating every other glacier. Now, of course, this one doesn't even have any major deserts. It only has one minor one, which is kind of disappointing, but it is colder than Earth at not negative, but positive, at 51 degrees Fahrenheit. Moving on to this even further away gas giant, which is a whole lot bigger than this one. At around 230,000 kilometers, it has rings and is tilted kind of weird, almost resembling a planet that we know of. Now, of course, this one only has 3 degrees Fahrenheit, and it does have a lot of stripes. It's kind of unique. Maybe not that unique, but it's definitely still nice to look at. Okay, moving on. There's this one, which, I forgot about this thing. Yeah, it weighs around 23 Jupiters. Moving on. This one is really huge. Like, it weighs so much that I shouldn't even call it a planet. It says it's actually or the star, and it's really small compared to the star. I'm still added it. Ha ha ha. Ha ha. Take that. Okay, but really though, it's probably smaller because it weighs around 184 Jupiters and is almost twice as big. But then I still decided to add it because why the heck not? Okay, but actually though, it is quite weird. Like, it has a lot more oxygen than it does. It has a lot more oxygen and nitrogen than it does. Doesn't it look like this? A slightly different color, but it's similar to the gas giants as well. Now, of course, it's around 0.7 million kilometers, around 750,000 kilometers in size. And yeah, there's really not much to talk about it, though it does have some spots, like the sun. Well, I decided to draw them, and they were pretty nice. It also has a temperature of negative 21. It has several moons that are habitable, and I will talk about them. Now, of course, the moons of them, which they don't have names, but one of them is around 14,000 kilometers in size, and it has a thick atmosphere keeping it habitable. It also has a really strong magnetic field. Detect it. Now, of course, it's also partially habitable. Yay! It's also partially habitable. Pretty nice, I guess. Now, moving on to its smallest moon, which is kind of like a meta moon because it's orbiting another moon. It's around 842 kilometers. I meant like spherical, because the smallest ones are around 4 kilometers in size. Yeah, kind of small. But then Jupiter does have even smaller moons, around 2, even 1 kilometers in size. Now, of course, that's not really much to talk about. But then there are also a lot of other ones with pretty uniqueness. And there's also some quite unique moons in the other gas giants too. But then we gotta talk about this planet before we run out of actual time. Of course, to talk about it, let's actually talk about it. Okay, so this planet has a similar color spectrum to basically Neptune. Just that it has a lot more stripes and is a lot more unique color. Now, of course, as you can probably see in this photo, which I actually drew. Okay, moving on. So you might have saw that the first one and the next one were kind of similar in size, overall shape, and even color. Okay, why didn't I have shape? All of them are the same shape. Jesus Christ. And of course, you might have also seen that they had spots. Yes, the next one that I'm talking about right now is a bigger spot than the other one. But yeah, that's really it. Of course, it also has really good stripes, and I really want to look at it for a while. No, but of course, it does have pretty cool stripes, and some of them are weird colors. It also has kind of weird moves. One of them has such a thick atmosphere, similar to the other moon that I talked about, that it just got liquid water. It's just it doesn't have a magnetosphere, so it might lose that water. But good God, it's in its magnetosphere. So yeah, that's pretty good. Now, of course, this name is blank. I did not decide to give it a name. Now, of course, its color spectrum is a little bit off compared to Neptune's. It's also more saturated too, giving it a nice little color to it. Now, of course, that's really it, and it's also quite cold compared to the other planets, especially that star, which is only negative 21 degrees. Mine seemed well, of course, basically the actual heat that it makes. Then it would have been around 200, it would have been almost 400 degrees Fahrenheit. Yeah, I told you that. But basically, it's at negative 100 degrees. So yeah, that's quite impressive. Now, of course, these outer Kuiper Belt objects are definitely something to talk about too. Now, of course, these planets all formed at very similar times. So yeah, that's definitely nice to add about. But then, well, yeah, that's pretty much to talk about it. Also, it's pretty nice moons. Some of them even have rings and asteroids around them. And now we're starting to move back to the dwarf planets again, which I'll not be mentioning, but some of them do have thick atmospheres enough to actually make themselves habitable, just like other things too. Now, yeah, that's really it to talk about it. So, bye-bye. I might actually talk about the history and the future of it, because you already seen my history of it. So, goodbye.